In the current scenario, what are the challenges for water? Actually, this year the theme of this World Water Day is valuing water. That means how much value we are giving to the water. And specifically when you are from that region where water is scarce, so you are understanding the value of water. Suppose I belong to the Bihar, so I don't think that in Bihar there is so much problem of water scarcity. There is a problem of abundance of water in the time of flood. So maybe the value of water for region by region or spatial location, the value will be different. And obviously it's not a classification only based on the political geography, like based on the states only. It's a value also depend on, suppose if I am a homemaker or a housemaker, so value of water for me is a different. So valuing a water is an entirely individual concept. That means how we are looking into the water is the like there is a one concept I have heard about, the my water my way. So I would like to urge on that and this World Water Day that my water my way, you have to change the concept. This is the world's water and there is the way of integrated way. You cannot do that my water my way, because sometimes I have looked into that, the people, I have just bought the water bottle, I can waste because I have a purchasing power. So that is not the good sign if you are doing like that, because all of we are from the engineering, we can say that we are from the allied background. So maybe we are having the capability to purchase the water, but the thing is that if we are thinking the lower people, the people who are not able to buy the fresh water, so what they can do and why the things came. Actually, sometimes we are just blaming the river infrastructure and all those things, which is coming into the news regularly, that this is due to that particular dam, this is due to that particular infrastructural measures. So really, is it like that? Or there are some other issues which we are not actually seeing or we don't want to see actually. So that may be the reason. So I'm just straightforward coming into the challenges. So for India, you can easily identify that the distribution of water is not uniform. That means from where we are getting the water. The two sources are there if you just classify the things. One is the rainfall and other is the snowfall for the perennial river in the Himalayan belts. So we are getting the water from only these two sources, or you can club it as a precipitation only, the source. And we cannot, that means do much more about that. That means how much amount of rainfall we are getting. It's a call of nature. And second thing is that we are trying to, that means get into that via the climate change. That means we are changing our lifestyle in such a way that all of we are indulged in that. We'll look into that in the next later part, that how we are doing that. And maybe we are not aware about that. We are doing that, we are saying that I have not done anything. The peoples are doing, all the peoples earlier they have done. So that is the point. And the third, and I think the most important point for India is population. Because all of you know that how the population is increasing. I will show the statistics also, which is having a clear cut. That means why we are having a water shortage. And the fourth thing is that urban expansion. And with the urban expansion, one thing I would like to also explain, there is the centralization of industry. That means suppose we are living in Delhi, we are living in Ahmedabad, we are living in certain cities. We are having a limited amount of cities because the industry development within that reach is there. So that is also challenge, because water is limited for, suppose I am living in Delhi. So water for Delhi is constant. Or if you will see the total amount of rainfall during last 100 years average, so it's not so much change, but the population of Delhi has increased manifold. So an urban expansion is why it is happening. We cannot stop also, because it is happening due to the centralization of industry in one location. So we also have to think that why not we are establishing the industry in the village part also. So that would be the policy part also for the government, how they are trying to establish the industry apart from a city centric. And the human health is also, because how we are getting deep into the water problems, and all the health is related with the water. If you are getting a good water, you are having a good health. So human health is directly linked with the water. And the next point is the environmental restoration. Because when, as a water resource engineer or as a hydrologist, what we are thinking that we are only that means having an idea about hydrology and hydraulics and all those things about the river engineering. But we sometimes when we are doing the works, we forgot the environment, because we have to look into that. Earlier I said that we have to go as an integrative manner. Otherwise we will lose something. And we will then in the future we will blame the past and all those things. That is the continuous process, and ultimately we will not get the benefit what we are trying for. And the food security, obviously food or agricultural activities is directly related with the water. So if any scenario change in the water resources, so it will impact the food security also. And the eighth and ninth is very important, that is the economic balance. And you can understand that, suppose if I'm very rich or you are very rich, so you are not having any water problem, you can purchase the water from the distillery and you can use even for bathing purpose. So there is all about the economics somewhere. If you think about that, something is, if all people of world is having a similar income, so maybe they can get the water easily. So there are some economic things also involved in the water. And finally is the institutional mechanism, because we are having a academics institution, we are having a research institution, we are having an industry also. So there are different institutional mechanisms. And I think the government of India has merged this Department of Water Resources with the different departments, because it's a very difficult to collaborate. If you are having such a vast sector, water is having everything. So institutional mechanism, maybe like that, it's you can collaborate with each other. Otherwise, what will happen? I have taken some one decision and other department has taken some another decision. And ultimately the problem what you're trying to solve, maybe it will not solve. So these are the challenges, and I will just go one by one. That means how it is happening. Suppose this is the map of India, and you can just see that how the water distribution, that means rainfall distribution throughout the India, like it is a lesser for some portion and higher for this particular region, like Bihar, Northeast, UP. So the distribution is natural. You cannot say that lots of changes has happened in a average manner. As you can see that if you look into the data of whole India average, so you just find out that the average is varying from like 1000 to 1400. So it's a variation is not so much alarming, that I cannot say that variation is not so much alarming. But the what by alarming is that you just look into the population graph. It's continuously in India. In 1951, something like 34 crores only, and now we are touching to 140 crores. So what it signify actually, if you just signify in the simple manner, so you just find out that the supply is almost consistent. Nature is giving water to us, but the demand has increased manifold. That means because every people wants water for drinking, for kitchen, for their other purposes, and as the population increases, the agricultural demand increases, so that for the production of crops, the water requirement is there. So obviously, in a background, you can say this population and that means demand supply gap is increasing, and that is the reason of worry for India specifically, because demand supply gap. How you can reduce that demand supply gap? That is the challenge for the water resource engineer, because you can see how you can increase the supply. So increasing the net supply, that means you cannot increase the rainfall. So how can you increase the supply for the household and other purposes? First thing is that if you reuse the water, so maybe some amount of water which is going to be waste and directly going to the river, and via that it is going to the sea, so that water can be reused. And second thing is that available water utilization, what today's our prime minister has also launched this particular campaign, catch water catch the rain campaign. That means if you'd like to have a small structures that we are having a tradition earlier, but now the tradition is going on. So that water we can use for a smaller area. Because if you just go to the simple statistics of a different river basin, you will find that the major river basin like Indus, Ganga and Brahmaputra, we are not utilizing more than 40% of the water. So rest is going, the fresh water is going as a waste in terms of fresh water, because everything is just circular. No water is going to be, ultimately it is going contributing to the water cycle. But for the peoples or for the society, we are not getting that amount of water. So available water utilization, from there we can increase the supply and water reuse. And second thing is demand. How we can reduce the demand? Suppose I am asking for 100 liter of water. So obviously my demand I can reduce only by myself. How I can reduce my demand? I will just come into that part also later. It's very interesting for a student also to run that particular thing. And second thing is increase efficiency, because as all of you are aware about that, how the water, fresh water categorization in India, that means how it is used. First thing is that it is mostly used by the agricultural sector, irrigation purpose. So we have to increase the efficiency. There is no way, because 85% of the water, more than 80% of the water is being used by the agricultural or irrigation industry. It's I am saying the industry, but it is a sort of water industry. And how we can increase the efficiency? The thing is that there are lots of development in the area of agricultural or irrigation efficiency. But what is the bottleneck there? Suppose if you go to the farmer and you ask to the farmer, please use the drip irrigation technology, please use the other technology. But there is the involvement of cost also. So how a small farmer can bear that cost of drip irrigation? So we cannot, that means give the burden to the farmers also, because the income to the farmer is also matter to their lifestyle. So there is a very much, you can say that there is a complicated thing that you have to do deal with as a water resource engineer or academician. And the third thing I have mentioned here in a whole cycle, that is E&M, that means engineering and management. Because as an engineer and engineering and management, there are 2 points. First, I will start with the second point, that is the individual accountability. And that is totally depend on us. That means how we are accounting water for ourselves, our family and nearby peoples. So that is the individual accountability, and that is very much important now. Because if we are not accountable in my family or my society, so that means we cannot blame to others. That means that generation has done all those wrong things and all those things. So we have to play our individual accountability as per our, that means it's depend on our strength. I'm not saying that anyone can solve the problem of water for whole world. It is not possible. But we have to think about the individual accountability. And the first thing what I have mentioned is the context settings. It is more on the higher scale. You can say it's more on the higher scale. And in the context setting, I would like to mention that suppose in 1980s, there is a policy or there is a rule to do like this. But in the 1980s, the situations are different. Now it's a 40 years ahead. We are in 2021. So the context settings are same, and sometimes the departments or industry or anything, they are not ready to accept the newer things. We are not changing our context, either as an industry, either as a academic, either as a research. We are not changing our context. So we have to change our context setting. Otherwise, we are not able to provide efficient engineering and management to fulfill the supply and demand gap in India. It's only the saying part we will say on the different platform. We will talk about that. But ultimately, that means in my point of view, in 2030, the positions is getting worse than that. So we have to change our context setting and individual accountability right now. And if you, that means if you want to really celebrate the Water Day, just start from an individual accountability right now. That means what you are having, like the sir also mentioned about that, try to use the bucket. And I'm very happy to say that I have never used the shower in my 35 years of life, because I belong to the area where I earlier, that means from my all the studies from the coal mines area, and then there the water is very scarce. So I have studied. Right now I am staying in Delhi, and I have a lots of water in society, but that is my personal habit. So kindly take your individual accountability, how you are taking, and try to teach also 2-3 peoples that you can do that. What is the need of that? And I have just mentioned that the population things, and I have just taken a small example about this area. One of the areas nearby in coal mines in Dhanbad. And you can see the average rainfall is almost consistent if you just look into the graph. But the population from 1901 to 2011, it's increased 8 times. Almost all the cities, all the locations, even in India, 34 to 140, it's around 4 times. But the average rainfall is consistent about 13 to 1400 or 1250 mm for whole India. So the availability and demand is continuously, the demand supply gap is increasing. So we must think about that. And what I'm talking about, that water resource potential, regarding how much potential we have of fresh water and how much we are utilizing. So you can see that for a Ganga, Brahmaputra, for Brahmaputra it's far lesser because it's a very tricky river also. So we are not able to understand the rivers and river water. That means how we can use and what are the consequences if you are using a water directly from a Brahmaputra. So that is also the challenge, but we are having this gap, this possibility to fill the gap, because we are having a higher potential than what we are getting. But somewhere you can see that like Pennar or like other rivers, we are getting higher from that water potential. So we are getting maximum benefit out of that. And according to the Government of India projection, you can just look into that, why I am mentioning the irrigation part regularly or agricultural. That means it is the highest demand maker. Like in 694 to 543 is irrigation demand in BCM. And even in future, what they have projected, it's almost the ratio is same. So where we are increasing the irrigation efficiency, where we are using the water productivity, why we are not going for like if you are purchasing any electrical equipment right now. So there is a energy rating. Why not we are having a water rating for any products? So we can do as an industry or as a designer or as a academician, we can just promote these things that why not we have. If we will ask the question and we will also propose the solution. So we will get the solutions, definitely. There is no doubt about that. And the next thing is that how the variability of groundwater, all of you are aware about that, how the variability of groundwater and why it is happening, we are also aware about that. Because we are giving the land, we are disturbing the hydrological lines where the aquifer is going from one side to another side. So actually anthropogenic activity is very much affecting the groundwater also. So whether we have to stop these activities or we have to do the activities with the engineering. Because we cannot say that I will not live in the house or I will not use the mobile phone. Is it possible? If the possible, the world will, that means go 1901 automatically. So there is no need of putting any type of hard side of thing. But because we are also increasing our lifestyle, our standards. So with that standard, how we can manage, that is in our part. And the next is a climate change. So obviously the climate is almost linked with all the parameters. and like water, energy, and land. And you can see that for everything. Like I'm just giving a small example that if the water level is going down, only not a single thing is happening, only the water level is going down. That is one of the problem. When water level is going down, and if you like to have a water, your pumping requirement is getting high. So that means you are using a higher fuel, that means a higher amount of fuel, and the wastage from that fuel, maybe that lead a wastewater treatment plant. So it is so much of link. If you are using one thing, so it is linked with the other things. So the second thing is that suppose water and land linkage. If you just go to the northeast part and you would look into that, every year Brahmaputra is getting eroded by a kilometer, square kilometer. So why it is happening? Because due to some anthropogenic activities in the mountain, or different dam formulation, there are sediment deficit also. And due to the sediment deficit, when river is having a sediment deficit, so they will take sediment or a soil from anywhere. So they are taking a water from the land, taking a soil from the land, and then they are going. Because it's like a simple mechanism of person. If you are hungry, so you will take the food. If you are not hungry and anyone just they have given unnecessary food to you, so maybe you can vomit to that. So that is the thing with the river also. So the water and land linkage is there, and otherwise all the things like water, energy, and land is linked with the climate. So obviously, if one thing as a researcher, I would like to mention that if you are trying to figure out all those things, it's not, it's look like that, how I can do that. So the best thing is that from where you can start, you just start. And when you are starting, you are going into the deep. So obviously we'll get the lots of complexity, and up to that your human knowledge, because no one is perfect, neither me and nor anyone can. So up to your knowledge, you can solve your problem, and you try to judiciously utilize that. So that is my argument. And the next point is that what I am mentioning, that challenge, that is the human health. And you just look into that, this figure, that means how much habitants is affected by the arsenic, salinity, iron, fluoride. And you know that some of this is the anthropogenic and some of due to the geogenic also. Like lots of chemicals are always present in the nature also that we are getting. And due to this presence of this particular metals or heavy metals, there are lots of health problem is there. Just 3-4 months ago, we have surveyed an area of Bihar where there is an arsenic problem. And we just try to find out that, because there is no certain data about that, how the problem is extending. So we went to the different medical halls who is selling the different medicines, or from last 10-15 years. So we have asked a simple question, that what type of medicine you are selling that has increased from last 10-15 years. So they have said simply that the skin diseases problem has increased. So if you just link into that particular survey to the water quality, so you find that in that area, the arsenic contamination has increased manifold in last 10-15 years. So somehow, if we are doing this type of interlinking in your study also, in your project also, so that is also the valuing of water. In apart from only the, I'm not discouraging any like hydrology or hydraulics part, because I'm also a hydraulic and hydrological engineer. But when you are thinking out of the box, when you are thinking apart from hydrology also, then you are getting actual solution on the ground. So that is my submission on this World Water Day for the students. And you can see that World Health Organization report that India is on top deaths due to the unsafe water. So you have to get into that safe water. And obviously for the safe water, either you have to become more rich, or you have to make your water more potable. So the two things are there. If you are more rich, then there is no problem. But if you are in a middle category and you would like to have a safe water, so you have to think beyond that. And this is the just natural disaster which has happened globally. And you can see that how the all type of like flood has increased in last 10-14 years, and droughts also has having an increasing pattern in the, so frequency is no doubt is changing. Earlier the flood is coming in a Bihar in maybe 3-4 years. Now it is coming regularly in every area. Somewhere where the flood is not coming earlier in UP. So, but now the flood is coming. So some of the disaster is man-made also. That means we have made some changes, and maybe our vision is that time is very short term. We just thought about that 10 years or 5 years. So now we are getting that problems also. So we have to thought at least for our lifetime, like 70, 80, 90 years, what is our lifetime. And I have just tried to mention some of the dimensions of water, and I have specifically highlighted here water economics and finance. Because as a water engineer, or when we are doing a MTech and PhD, so we are only focused on that. Okay, we have to just calculate the hydrology, we have to calculate the hydraulics, we have to calculate the groundwater. But somewhere we are missing water economics and finance. And there, when we are missing this part to link with that, so then what is happening actually when we are going to the field or for the industry? So we are not actually making the viable projects, or we are not able to make the viable solutions. So water economics and finance is very much important, and we have to look into that part also. And I have advocated on the lots of platform that for the academic institution and for the research institution, they have to clearly start this curriculum also for the students, water economics and finance, because it's directly related to the actual or practical implication of that. And apart from that, we have already discussed about the water resources scarcity, supply, sanitation and health, climate disasters. Transboundary waters is also very one of the interesting concern, because what we did that in the constitution we are having water is having in a concurrent issue. So both the state and center is dealing. That means we have divided actually water into the political boundaries. Either it is a state or center, it is a political boundary. Actually, the water is having their hydrological or hydrogeological boundary. So why not we are thinking about that in an actual sense, in a policy sense, while we are still dealing with the hydrological, that means only the political boundaries. And right now, I think you must be aware about that. Apart from this Catch the Rain campaign, today one milestone for water resource project also there is a signing agreement between the UPMP and government and central government for a Ken-Betwa interbasin transfer link. It's after 25 years. So much time it has taken to clarify all those environmental issues, design issues, all those things. But now I think today's 3 p.m. or 4 p.m. there is a time to sign that agreement for both chief ministers and Union Minister of Water. So that is I think one step ahead what we got an interbasin transfer. And I guess if you are aware about the interbasin transfer, where we can transfer the excess amount of water from that basin where there is an excess amount of water, and the basins where there is a lesser amount of the water. So Ken-Betwa is I think first signing agreement between government of Madhya Pradesh and Uttar Pradesh. So that is going to be happen today only. So this is the good sign, but still I believe that if we reduce, that means we remove this particular political boundary concept in a water resources, so maybe we will get a maximum benefit out of it. Obviously, we have to see the institutional mechanism of that. It's not so easy that only the remove that part. So we have to see in the institutional mechanism of that part also. And the thing is that means what we have discussed, that why the challenges of the water is there and what the solutions are. So we have already discussed about that. We are not having some unified vision. Suppose if I am a water resource engineer, I'm thinking about the water. If I am an environmental engineer, I'm thinking about environment. If I'm suppose a finance side, I'm just thinking about the finance. So that means we are not bothering about all other things to integrate the things And the second thing is that lack of leadership and political will. That is very much important for any country. Like a democracy, we are having a democracy. We cannot impose anything on any people. So the leaders and political wills is playing a major role. And you can see in last 18 years, if you'd like to have a change or transformation on that, and the government is doing that part. So somewhere we are lacking that part, and maybe in some part still we are missing on that part. And the third and important point I would like to here highlight is the lack of data collection and sharing. Because suppose if you are not having any historical data, so what you will do for a future? So we are having lots of, that means we are having a lack of data collection, but right now from 2007-8, the data collection mechanism has increased, and private industries also invested on that part. But still the sharing mechanism is not so much clear for a student, researcher, and all those things. In fact, I'm just trying to share here that if you would like to collect the data for India, you can collect from a US website, but you cannot collect from an Indian website. So it's not that means very practical sign for any development. Because if you not like to share the data from each other, that means it is a resource or it's a hidden things. That means how can you manage those water in a best way? And the last thing is the system thinking and integration, that we are also lagging, but we are trying to integrate the things right now. And that's why the some of the area we are improving the conditions also. And just I would like to approach to bring the change. That means what type of approach, if we will take that, maybe that bring the change. Our approach regarding any project execution or anything, that means that is about the actions and outcomes. We are just looping in a single loop. That means suppose if we are having a flood, just make the embankment. If you are having a drought area, just make some type of talab or something like that. So we are only doing that part because maybe after making a talab, you will get temporary solutions. But what will happen? Suppose I'm not discouraging any event, but suppose if you are having a larger dams, if you have invested 70,000-80,000 crores for a dam project, and now suddenly this campaign has started, Catch the Rain. And what will happen actually, if you just realize in a simple manner, not go to very technical, because if you catch all the rain in your house or in your locality, the rain what is coming to the dam, that is also the part of watershed. So what will happen? Dam is underutilized. So is that so easy to run this campaign and that means utilize both the things in an efficient manner? So just not go for the actions first, think about that. And that's why I'm just going in the second loop. Just reframe the event. If you are doing, if you are making 1,000 of rainwater harvesting system and you are stopping all the water in your village, so what will happen to the nearby village where that water is only going through the dam? Is it possible, or it is happening or not? So you have to think about that part also. And in the third part, where the transformation will come, that I earlier mentioned, that it's a context setting or event settings. If any context has set for a 1970s or 80s, now we have to change that context. Otherwise, we are doing the actions based on 1970s and 80s, and obviously the outcome is not good as 1970-80. So we have to change, and we have to go to the third loop of transformation. So that is the approach where you can bring the change, and you are only the actor. As a student or as a new engineering commerce, I would say that you are the new actors that can bring the change for any sector. It's not only for the water sector or any sector. So that approach you have to use. And next I am coming to the very interesting part, and I'm just announcing from this platform that after this completion, I will share two links. One link to calculate your individual water footprint based on your knowledge. It's not knowledge, it's a simple calculation. That means how much amount of water you are taking bath for your car wash, for your utensil wash. So this is a UNESCO made tools. You just put that some amount, but be honest on that. Not like that, just fill anything is that. And you just submit a Google form is there. Submit to us and we will publish after 2-3 days after analysis. That means how the people's behavior and how we can reduce or how you can reduce. You understand that water footprint, that means suppose if you are using any product, if you are using a cocoa beans or something like that, so you are using this amount of water, 27,218 meter cube per ton. So if you are using a 1 kg of this particular bean, you are using 27,000 liter of water. In the same, it is already you can get from this research paper. So you will find that you are not using. That means you are not only the direct consumer of water, you are also the indirect consumer of water. Like if you are using any food, you are using water also, equivalent water of that. If you are wasting any food, you are wasting also water. So you must think about that before wasting any amount of foods. And you are surprised to know that in India, there is one survey by one of the global organization, and they say that per year 92,000 crores rupees wastage for the food. And you can understand that how big it is. If you are wasting a 9,200 crores of food wastage in a country where people are not getting the food, obviously you are wasting also the water in the same point of view. So you just kindly consider that if you are just if you'd like to take one chapati, I have seen in the hostels also, in the BTech, MTech and PhD hostels, I have seen lots of students are taking a meal and then, oh, okay, today is not good, just waste it. So that is the habit that will become the habit. And when it will become the habit, so obviously when you are trying to come into this water management and all those things, you find that it's a very difficult. So and regarding this water footprint, actually this is the global scenario. And because India is not directly having any benchmarking of that, either it is a crop, that means agricultural products, or any industrial products. But right now the government has started lots of benchmarking scheme for a irrigation project as well as an industry also. In fact, Maharashtra government or some of the area in Gujarat also, they are doing the irrigation benchmarking part. So that is the good sign. Obviously, you can know that, okay, 1350 liter of the water for 1 kg growing of wheat. Otherwise, there is a diversity also. People of Bihar is using 4,000 liter and people of Haryana is using only 3,000 liter. So why the gap is 1,000? Maybe there is a change in soil or climate, but not so much that people is using lots of difference in the amount of water. So you have to also learn about the technology, how they are growing and why they are using less water. And the second thing is about the cropping patterns also. Like government is continuously promoting in Haryana. Haryana is a water scarce region. And government is continuously promoting that don't grow paddy here. But sometimes when you are at the farmer side, you know that if you just grow the paddy, you are having a ready market. You can go to the market and earn the money. And government is trying to convey that, okay, you just grow the wheat because wheat is less water consuming than the paddy, but there is no market for wheat. I'm just giving an example. So what the farmer will do? Obviously, they will grow the paddy. So somehow we have to also integrate the mechanism with the government. If you are trying to convince the farmers or lower level peoples to do that, so there should be conveniency, active mechanism for that. Otherwise, people will never go for that part. And I have mentioned this water footprint for like if you are using a smartphone, it's a global average only. For if you would like to take a pizza or burger, if you are having a car, if you're using a cotton t-shirt, there are lots of products. I've just mentioned that this much of amount of water will need. Maybe the amount will vary according to the condition also, but there is an amount involved. I would like to only convey this part. There's some amount and even higher amount of the water is involved over there. This is the actually engaging activity. I will just share after this completing presentation. I will share this part. This is the online link where you can go. You can fill your information. That means the information is like that: how much amount of water you are using per day or per year. Like that, questions are there. You have to fill that amount, and after that, there is a calculator, and you calculate that how much amount of water you are using per year, and then you can send this particular amount only on this Google link. I will share this link also on this platform. And after this, I think I would like to conclude this session, and I would like to thank Dr. Darshan and Principal Sir and all the dignitaries who has presented here, and all the senior faculty members. And I would like to also thank to the student, because from where I would like to convey my message to the students, who is the new generation who is coming, and they are fresher to do lots of enthusiasm to do that. So we have also started 1-2 programs, like it's a program of Soch, where we are trying to do some behavioral change for a child. So we have taken this program as what you think about the water, you just sketch it, paint it, write it, anything you would like to that below 12 years children. So you can do that, and it's a regular program. It's going on, and every month we are just getting some prize or some incentive to the child who has participated on that. And we are also getting some of the useful information that what child is thinking about the water, and how we can just change that thought process of children. And apart from that, we have also started one small program. It's for final year BTech students or final year MTech students, where we are enrolling some of the students in our startup company. And we are not specifically giving any training out of that. This is a complete industrial training program where you can learn how the industry is behaving, what is lacking between the academics and industry, what is the lacking between the research and industry, and how you can fill the gap. So it's a day-to-day work, and we are taking a student from 2 months to 6 months as per their curriculum on the colleges. So this is also in this program, we are taking around November and December to the peoples, and some of the NITs people are right now working on that. And recently we have launched a e-magazine, which is a Pani Teri Kahani. It's a story of water, and we have also got a thankful appreciation from BN Navlawala sir, who is the advisor of Honorable Chief Minister Gujarat. So in that magazine, what we have targeted that we are showing all the face of water. It's not like that as a hydrologist or as an environmentalist, we will show only the single part, or as a socialist or as an economist. So we will try to show all the parts. If you would like to contribute, you can submit your views or articles in this mail ID. And thank you all for giving this particular chance, because as a very first stage entrepreneur, you can say we are not having, or I am not having a lots of experience. I'm having a limited experience of 10 to 15 years after my engineering, you can say, and before 25-year experience of coal area, where I'm just getting water scarcity all the time. So thank you very much. I'm just stopping this sharing, and then I will just share that, and you can just try to give your figures on that if you'd like to do that, and you just submit on that Google Meet, that means Google Sheet.